data is distributed, what is the difference? Okay, what is the spread from one variable or from one person to another? What is the difference? So we are looking at the difference in this data. So when we are looking at the interquartile range, um, first of all, we need to understand that when we have a data set, okay, when we have a data set, we can divide this data set into some parts, okay. For instance, you remember that the median divide the data set into two equal parts, and it picks the value that is at the center, right? The value that is on the middle there, that's the median. Okay, are we together? Yeah. So when we look at the interquartile range, so you'll find that the interquartile range is interested to find the variance or the difference, okay, in the values that are almost at the middle of um, the data. So quartiles, the data will be divided into some parts. When you're talking about the interquartile, you can divide the data into some parts. Let me do this. Okay. Um, yeah, or I use this one. Yeah, you have to divide the data into some parts. So maybe we have a data like this one. We have one, we have two, we have three, and four. Okay, so this is the data that we have. So we are going to divide this data maybe into uh, four quarters. Okay, we are going to divide this data into four quarters using percentages. So the first one, this one, is going to be from here, it will be 25. Okay, we are going to divide in two quarters. So 25 is a quarter of 100. So we are dividing this as 100% into four parts. So when you divide into four parts, this will be 25. These two again, it will be the data again 25, and these three will also be 25%, and this last it will be 25%. So these are more like um, the the range, okay, when you divide this data. So when you add all these 25, they will give you 100%. So we are just dividing the data into quarters, okay, just dividing the data into quarters. So the the interquartile, now the interquartile range focuses on the difference between the range, okay, in the middle of this data, in the middle of this data, okay, where the data is divided to 50%, 50%. So it focuses on the mid. That's why it's interquartile range. So it focuses on the middle, and is given by this formula, which is quartile 3. Interquartile range is equal to quartile 3 minus quartile 1. So it will give you the value that is on the mid. So it will subtract this one, which is the first quarter, okay, from the third quarter, this one here, okay. it multiplies subtract the third quarter minus first quarter. Okay, now where quarter 1 and quarter 2 are at the third and first quarters, okay, first quarters. So now this one, if you are given a data, okay, you need to determine where is the first quarter and where is the third quarter. So you'll be given a data set. Maybe you are given a data set like you have the age for people. I think there is this one here. We are given this data. So you need to know where is the third quarter and where is uh, the first quarter in this data. Okay, so this data have to be divided into 4 quarters. So now you need to know where is the first quarter and where is the third quarter. Okay, so this is the formula that we are given. So we need to know where is the first quarter. So the first quarter is on position 1 over 2, 1 over 4 times n plus 1. Okay, so you need to divide this data in 2 quarters. First, arrange the data in ascending order, then assign positions. So we are going to say, let's arrange this data first in order. So start with 12. Okay, we have another 12. No, which one the smallest here? Yeah, 11. Yeah, so start with 11, then 12, again another 12, then 13. Is the color that I'm using visible? Yes. Yeah, 13, then 15. From 15, go to 17, right?
Yes.
17 and 21. Okay, so you first arrange the data in ascending order. Then you assign position. This 11 is on position what? Position 1.
1.
Okay, we have 2, we have 3, 4, 5, 6, and 7. So here n is going to be the total number in this group. That will be our n. So our n is what? How many number do we have?
7.
There are 7. Okay, so that is our n. That's the total number we have. So remember our formula. We want to find the interquartile range, which is quartile 1, quartile 3 minus quartile 1. So we are told that this these quartiles, quartile 1 is on position, which is given by this formula, 1 over 4 times n plus 1. So let's go to the numbers that we are given here. Okay, so we're going to say 1 over 4. Okay, multiplied by 7 plus 1. Okay, let's do the math. What's the answer here? So this will be 1 over 4 multiplied by 7 plus 1 is what?
8.
8. Yeah. So this will be 1 over 4 times 8 is what? If you want, you can put 1. What is the answer?
2.
2. Yes. So the first quarter is on position what? 2.
2.
So this is the position. The first quarter is on position 2. Then you go, the formula for the third quarter is what? Is 3 over 4. Okay, 3 over 4 times 7 times n plus 1. So we go back here, we say 3 over 4 times 7 plus 1. Okay, what is 3 over 4 times 7 plus 1, which is 3 over 4 times 8?
6.
6. Okay, yeah, 6. So the third quarter is on position 6. So you have position 2 and position 6. So the interquartile range now is going to be interquartile range is going to be, what is the value on position 6?
17.
17. 17.
What level?
Eh?
Isn't it 11?
These follow this one that we have arranged in order.
Oh, okay.
Yeah. It will be 17 minus the value on position 2,
12.
12. Yeah. 17 minus 12 gives us what?
5.
5. Yeah. So the interquartile range is equal to 5. So that is the interquartile range. Okay. Any question on this one? So the most important thing, you have to arrange these values first in ascending order, starting from the smallest to the highest. So if you don't arrange them, you see that you have to subtract 11 minus 13 if you just follow the way they are, and you get a wrong answer. So first arrange them in ascending order, then assign the positions, then find where the first quartile is and where the third quartile is located. Any question on this? Any question on this? So we go to another measure of variability, which is the variance. This one is called the variance. So the variance is an ideal measure of variability because it takes into account all observations, all the values. Okay, this one take into account all the values that we have. So this one is more like the way we calculate the way we calculate the average or the arithmetic mean, which takes into account all the values, all the observations that we have seen. Okay, so it measures the relative scatter of individual observation from bulk, which mean of them. So we need to measure the relative scatter of all individual, the relative difference of all individual. Hello? Hello? Can you hear me? Okay. Yeah, so first thing that we look at in the when we are dealing with the variance, first we need to find the difference of all the individuals from the mean, from the average mean, or from the average of that value. Okay, so that is number one. So it looks at the relative scatter of individual observation from the bulk mean of them. So first we need to find the mean of the data, then find how far each individual is from the mean. So for instance, we have this same data um, where we want to say these are age, okay, age range for the people or for young people. This is the age range for young people. So you want to know, first you want to find the average age. After you find the average age, you want to know how far each person is from the average age. Okay, can we do that? What is the average for this age group? What is the average here? You want to use this same data. 11, 12, 12, 13, 15, 17, 21. Let's find the average or the arithmetic mean. What will be our arithmetic mean? Anyone to lead us in finding the arithmetic mean? Anyone to lead us?
You are saying how to go about finding the mean.
Yes.
We are going to add all the answers in
We,
the data set.
we add all the values in the data set, then
Divide by 7.
yeah, divide by 7. So let's add them. 11 plus 12 plus 12 plus 13 plus 15 plus 17 plus 21 gives us what?
101.
Divide by 7,
21.
21. Okay?
14.2. 14.4.
14.4. Okay, so we have found 14.4. Is that what you have found, all of us? Because me, I'm not calculating. So I'm following what you have given me. 14.4. So now, when you are dealing with a variance, you need, after you found this one, you need to find the difference between this, okay, and each individual in the data set. Okay, then that difference that you find, you have to add all the differences. You have to square them, then add all these differences. Okay, so first let's find the differences. So start with the 11. You have to subtract 11 minus at 14.1 minus 11, it gives you what? We want to know. It gives 3 3.4, right? 3.4. Then is that a hand? Yes,
Yes,
Madam.
sir.
Yes.
A little bit behind. Maybe you can, yes, we can just go back to our subtract, where we subtracted the, is it from 7 over 101, then we got 21.
Okay, so when we add this one,
How did we come to 14.7?
11 plus 12 plus 12, we find 10 what?
101.
10.
No, up to 21 there.
Yes.
Just wanted to understand how we got to 14.2.
Yeah, that's where we are going. So when you add this one, they give you 101. Is that what we found, all of us? Hello? Yes. Then divide by 7. What is the answer when we divide by 7?
14.4.
So that 21 is not the answer that you will find after dividing this one. It's 14.4. That's what you have found, right?
Yes.
Yeah. So now, this is, we assume that this is the age, okay? These are age for each person in this data set. So now, you want to find how far each person is from the what? From the mean. Our mean is 14.4. So you want to find how far each person is from the mean. Are we together on this one?
Yes.
Yeah. So that is what we want to find. So we need to subtract, okay, each person from the mean, okay, each person minus the mean. So this is the formula: x minus this is supposed to be x bar, which is the mean, okay. That's what we need to do. We need to subtract to get what they are saying here: relative scatter of individuals observation from the bulk mean. So we need to subtract that. Then or maybe we can finish this one. Then after that, we want to find the total number of people in that um, sample that we are given. So after we find the total number of people, what is the total number of people?
7.
Is 7. Okay, we are given the total number of people to be 7. So when we are given this 7, we need now to, yeah, it's 7. So when we are given this 7, we need to find what we call the value which is independent from deviation, okay. So this value is called the degree of freedom, okay. We need to find the degree of freedom. So degree of freedom is given by n minus 1. So subtract n minus 7. 7 minus 1, it gives you what? 6. Okay, this is the degree of freedom from this value, from all the data set that we have. Okay, then here what we need to do now, is to use the formula. Let me check this formula. Yeah, use this formula. The variance is found by using this formula. Okay, the variance is found by using this formula, which is the summation of those differences that we find of each individual from the mean. We add them, all of them. Then we have to square to avoid summing up to 0. Okay, we have to square them to avoid summing up to 0. Then we divide by n minus 1, which is the degree of freedom. Okay, are we together? Yeah, so we are going to say, to find the variance, we add the individual differences that we found, how far each individual is from the mean. We are going to add them. After that, then the answer we find, we divide by the degree of freedom. Do you know how to find the degree of freedom? So the degree of freedom is found using the formula n minus 1. Okay, n being the total number of values in the data set, then you subtract by 1. So here we had how many values? Let me go back a bit there. How many values do we have here? 7. So what is going to be our degree of freedom?
7 minus 1.
Yeah, 7 minus 1 is going to be 6. So that will be our degree of freedom. So you need to subtract that one from the degree of freedom. Okay, then yeah, we have to divide by the degree of freedom. We will find the answer after we do that. Any question here so far? Any question here?
Yes, I want to find out for a clarification.
Okay.
So we have these 7 characters.
Yes.
So you mean the way we did
Okay. Yeah. So it was 14 point what? You know, what was the last value? 43 point 43.6. Okay. So now we have found this one. So we need to do the summation where we have to add all the values. So let's add them. The first one is 11.6, right? Plus 5.8 plus 5.8 plus 2 plus 0.36 plus 6.8 plus 43.6. It gives us what?
75.96.
75.96. Okay, this is what we found now. So once we find this one, we have to divide now. This is the total sum. We have to divide by the degree of freedom, which is what?
6.
Which is 6. This one is going to give us what? It's giving us 12.66. Okay, this is 12, not 17. 12.66. Yeah. So this is our variance now. This becomes our variance. We have found the variance. Any question? Any question? Any question? Any question?
So for a moment I was booted out, so I didn't want to interrupt, but I got lost at some point because when I came back I found you now. You are already submitting. So somehow I'm lost.
Okay. Yeah, you are lost somehow. So where do we start from?
I think I ended on where you were talking about the formula.
Okay, yeah.
Yes.
The formula X.
That's why I was stopped out. Yes, yes. We are talking about the what? The formula. Yes, the formula.
Yeah, this one. Yeah, this is X.
Yes.
Yeah, so this is the formula for finding the variance, Madam Bridget.
I want to find out what is X bar. Where are you getting the 14.4? So on the X bar, that's where I was putting out.
Oh, from the X bar. What is the X bar? So the X bar is the average value or the arithmetic mean for the sample. Okay? Arithmetic mean for the sample is called X bar. Then arithmetic mean for the population is called mu. This one, this symbol here, which is more like U. Actually, this one is supposed to be this side. It's like, how do they write this one? It's like this. This Kawani is supposed to be this side. So what is the difference between a population and a sample? Hello? Madam Bridget, what's the difference between a population and a sample?
I think the population is the total number of everyone. Then a sample is when you just pick out, not really everyone, but you sample out.
Yes. So those ones that you sample out, you can find the mean for them. That mean is called X bar. It's denoted by X bar. This just is a symbol to show that now you are dealing with what? With the sample. For someone to know. Someone, when they see X bar, they will know that you are dealing with a sample. When they see mu, they will know that you are dealing with now the entire what? The entire population. Okay? Yeah. So now we say this summation. This formula is summation of X minus X bar squared. So X is the total, is individual value in the data set. Then X is the arithmetic mean. So we went to our data set, which is somewhere there. Where is it? This data set which we are using. Okay? This data set which we are using. So the first thing, we have to find the arithmetic mean or the average for this data set. Okay? So you have found the average. What's the average? How do you find the average? You add all these values, divide by the total number of values. So you add all these values which we found 101. When you add them, divide by what? 7. Yeah, we find 14 point what? 0.4. So this 14.4 becomes the X bar. Okay? This is arithmetic mean, which is x bar. So x bar is equal to 14.1. Then you subtract, okay, 14.4 from each of these values, the individual values.
Okay, that's why I didn't get it.
Uh-huh. Then after you add, you have to sum them. Add. After you find the values, you add. After you subtract, you add the answer that you find. Now you have to square each answer, because if you don't square it will give you 0 sometimes, because of those negative when you are subtracting. So you add, and the answer you find, yes, you have to square them. That's why there is this square. Where is it?
Square them, that's what you subtracted.
The answer that you find, like 14 minus 11 minus 14.4 is what?
It's about, is it 3 point?
No, it's not 3.4. 11 minus 14.4. What's the answer? It's not 3.4, it's negative 3.4. We found is the answer is negative 3.4. It's not just 3.4, it's negative 3.4, because we are removing a larger number from a smaller number. Yeah, so it gives us negative 3.4. So because of these negatives, we need to rule out the negative by squaring it. That's why we are squaring each answer that we get. So when we square negative 3.4, it gives us 11, positive 11.6, which we have here. Okay, so this 11.6 is as a result of squaring this one. After you do that, then you divide. You find your variance. Is it clear now?
Yes. So you only square when you get a number with a negative.
No, everything you square them.
Okay.
You square everything. Yeah.
Okay.
Then from there, after you add those differences, you divide by the degree of freedom. You get this one, 12.66, which is the variance. Then we are done with the variance. Okay. So after you are done with the variance, the last part which we want to understand is the standard deviation. Okay, the standard deviation. You find now the standard deviation. The good part about calculating the standard deviation, if you have already calculated the variance, you don't have to sweat much. Okay, because the standard deviation is the square root of the variance. Okay, the standard deviation is the square root of the variance. That's why we have seen this formula, we have given here. Have you seen this formula?
Yes, sir.
Yeah. So if you look at this formula, you find that they have square rooted the same formula for the variance. You have seen this is the same formula for the variance, which we have just square rooted. You have seen it?
Yes, sir.
Okay, those that have conversation, kindly mute your mic. Yeah, so you just square root now the variance to find the standard deviation. So this 12 that you have found, square root it. What is the square root of 12? 12.66. 3.55. Okay, 3.55. Oh yeah? Then after you find 3.55, you have found now the standard deviation. So now we come to the conclusion. So when you are reporting, the most thing that you have to report, especially you find this one in the research, you have to report the mean and the standard what deviation, or you can report the median and the quartiles, but never report both. You can't report the mean and the standard deviation, then again you report the what the median and the quartile. Just report the median, the mean and the standard deviation, or you use the median and the quartiles. But the mostly reported one is the mean and the standard deviation. So from this data set that we have here, we can say the average age of these people is what? Hello, madam. Or maybe they are not in class. Madam Judith, kindly mute your mic. Thank you.
Come again, sir.
Yeah. So, from this data set, if you are to represent now this data set to someone to report what you have found, you are going to report the mean and the what? The standard deviation. Okay? You are going to report the mean and the standard deviation. So you're going to say the average age for these people was 14.4 and the standard deviation was 3.55. So someone will know that majority of these people are aged around this age, which is 14.4, 14 point what? 14.4. Then the standard deviation, which is the deviation, the standard deviation that each person is, how far each person is from the mean. That now the average variation is 3.55. So it just indicates how far each person is from the mean. Okay? Is it clear? People are answering with a very low voice. Hello?
Kindly go back to the formula. I want to put the formula for the standard deviation.
Oh, the standard deviation.
Yes.
Okay, so this is the formula for the standard deviation. So the standard deviation is the square root of the summation of x minus x bar squared. You put these brackets, divide by the degree of freedom. Yeah, the degree of freedom, which is n minus 1. Okay?
Did we divide or we just found the square root?
We find the square root first. So like I was saying, the standard deviation in short is the square root of what? The variance. The same formula that we are using. So this formula that is written here is same as this formula. It has just been square rooted. Okay? It's same as this formula here. It has just been square rooted. So just have to square root this formula for the standard deviation. Just square root it. So this is same as this one. They have just square rooted this. Yeah, this we are seeing here is the same.
Okay.
Yeah. Mm. Any question? Any question? Okay. If all is well, then we can end here.
Sir, my request is please share this video as well so that we can go through.
Okay, I'll share it, but I just have to edit because it was cutting. So I have recorded more than one. So I need to merge them first. Then I'll share.
Okay, sir.
Yes, thank you very much.